Hi. Hello there. Guess who? It's me. And I have about a million things that I would like to show you. I won't have time. I guess I'll go with baby steps. One of the things I made is something that you might, if you ever work with video games, is a very rudimentary sprite class. If you don't know what a sprite is, well, you're going to see one if I run the program. Of course, I could not show it. Well, I can't pause. I'll just run it. The thing that I wanted for this thing here, see, it's going slow maybe, but these are those growing circles. Now that graphic object is doing its thing, and I'm not doing any screen redraw or refresh. This thing is doing what sprites do, which is remembering what it grew over top of, and then restoring that when it moves away. So it has its own little buffer where it maintains some bit of the screen that it's copied, and when it moves, it replaces it. And that's called a sprite that you use in computer games for graphics, high efficiency and so on. See, like the copy background, draw the image, restore the background when it moves, right? Here's an example. Changing the position if it's visible, and it has a visibility flag, and have the background, meaning that we have a copy of the background, and restore the background to the DC. This happens to be the memory DC, not the screen. Right? This is copying from the memory device context and restoring that. Invalidate this part of the screen where it used to be, and then move to the new position. And again, if visible, we have the background as set to false. Well, I could do that. Where could I do this is fun. I think draw here. Right. Expects this flag to be false, or else it won't copy the background, it'll just draw. Okay, and so that's why I gotta set it to false. Now it could have been set to false at a different stage, but I think it's fine here. And then also invalidate the new rect. So the two where it was and where it is get invalidated and drawn. Now all the drawing bit is in window clock, you recall. This is the draw. Okay. So this, and when this occurs, the regions that were marked as dirty will be blitted from the memory device context. So that means that I have a thing here that can move around and not disturb the screen. Not too much, because, like, for instance, I can mess it up easily. If I draw a line, say, see, it messed up my line because it wasn't aware that the background had changed, right? And it had a copy of the blank background. If I go out of this mode and come back, it's restored, right? function. I have a lot to say about this function stuff, but let me draw this function here. That's not y, that should be x, but anyway. So how do you like my little color box here? Okay, so here's another thing. Let's see, I don't have to redraw this part or redraw the whole screen or anything. It's because it's making copies of the background and refreshing it. You'll notice that I've got a bunch of new functions here and functionality in this dialog. For instance, there's this angle and world transformations. One of the things I realized too late is that I never needed I never did, I never will need anything more than parametric functions. I have, like, for instance, I have this natural logarithm, and it's an xy thing, so it can't be rotated because you can't rotate the world and expect that x to y mapping to be valid anymore. Let me just draw this one. It's at an offset 0. Now these variables, this should say x-intercept, and this should be slope, and this is right, slope at y equals 0 is the x-intercept, and this is divided by 10, so this would be slope 1. If I wanted it to have a slope of 2 or 2.1, and I wanted its x-intercept to be at 60, I do that, and there it is. Okay. Now you'll notice that this one doesn't perfectly calculate the endpoints. I've got that all fixed now. You notice those lines, which are parametric, everything's perfect. It doesn't miss by a pixel anymore. And the way that works is using the thing that I mentioned before, the 0 point thing, and that's how I do these too. They all use the 0 point algorithm to find out where their bounding points are. That thing has become multi-purpose, which I knew it would be. What other functions have I got? Elect, circle, closers you've seen. I wanted to add a couple more before coming on here. But anyway, these, see, this also is a log. If I put 0 here, it's not rotated, it's not offset. Make it dark blue. It should go right over that green line. Well, same, or did I change something? Well, it's not 15, it was 21 or something. And this was 7. 50. Oh, it did. No, it went right over the white one. The white one's gone. Never mind. If it didn't, it would have still been there. Anyway, the y versus x thing can always be obtained by no rotation and no offset in parametric form, where the parameter happens to be the x-axis. That is the parameter in these other cases, but I can rotate them and move them around and do anything I like with them, because like this sort of thing's not allowed with y of x, like parametric. If I put this at 45 degrees, will that do it? I can do world rotation or relative to self. I guess that's okay. Well, not a little bit less than that. That still looks like it might be 1-to-1. That's this one. See, it's still not enough. There's another problem. All I need to do to fix that, and there's nothing to it, is maintain a list of all those sprites, and then when there's a function called redraw screen, and at that point I would walk through that list and there's an invalidate function for the sprites called invalidate, and that tells them that their buffers are full of garbage and they have to make a copy. Okay, now that is not a function. It cannot be written in terms of an XY thing, right? But in fact, it is the same log function, and since it's going through that interface, that parametric function thing, it obtains the rotation ability and all those things. So all that's being calculated by that function is exactly the same as the one I'd made for the XY version, where the functions log, natural log. Well, and the saving should work now for most things. I'll fix that. Okay, this is the formula you can think about it. This will have this should say x int, sorry, go down. Not dx. Anything else? Constructor. Yeah. I'm telling you now that at when this thing crosses the x-axis, its slope will be this value, and it will cross that axis at x equal to this. Yeah, but I changed these. Oh no, not whole word. Okay. Get rid of that part. And that part. 11. Okay, that's better. Okay, and I'll let that be a puzzle for you. This happens, well, I think it is, happens to be the natural logarithm function. I hope it is. It's easy to test. I'll check in a minute. If it is, then if I put 10 in here, I'll get 1. Now, what about this? Okay, so this is the y of x function. In fact, what I could have done even, since what I did the same thing with the TS function things that are now just objects you can pass around. So I could have just put one of these inside of my parametric thing, right? And run this function, like have this as a piece of data to use. But anyway, I'm going to get rid of this. And they're all going to be parametric, and then I can just give everything this name, which is easier to type. Now, there are many things to say. So that's one of the things that I did that I needed to do. I fixed some bugs with saving. Now let me see if this saving is going to work. I'm missing some things. So this doesn't have the logarithm. So that won't save or load. I didn't add them all. I was working on a lot of other things. Especially, as you can imagine, that dialogue. Now why have I started this drawing? I was going to show you something. I think now. What was I going to show you? Oh, saving. See if that works. I don't need to be in edit mode. I'll go into the edit mode. Oh yeah, this is one thing that works now. I out of this. Suppose I'll add a function. It's not a good old sine wave. A y to x thing, which I should now put this into parametric form, and then I can make it go along this axis. Let's see, now let's make it go up and down a few times. Amplitude a little bit less. Not that low. 75. 75. Now you can see I added this selection. Phase shift either in degrees or in pixels. So I'm going to choose, when I choose pixels, it moves in the direction, it'll move forward, right? 20. If I choose degrees, it'll just do the normal thing it does for degrees. So I cheat a bit on this one, but it helps emphasize the point about these things. So if I've shifted this by 20 degrees plus, then the whole thing should move back. Well, that's not a very nice looking sine wave. I wonder why it's so crummy looking. Did I change something with my sine wave? I probably changed something to do with how many dots. As I was fiddling around with the thing that I'm trying to get rid of anyway, I probably messed it up. And see how long it's taking. There's something wrong with that. But that's not important. I just wanted to show you that it disappears when I go in here. And I've made some lines and things in here. Polygon thing. This is really polygon mode, not vector. And that's what I want to do. Is I want to make one more graphic object, which is a vector that has like a little arrow on the end, you know, like that. Just an object. It takes 2 points and a direction, and I'll just add 2 extra. It's very easy to do. Let's show you how you do it. Suppose you have a vector like that, okay, and you want to draw some little arrows. Well, you take this point. Let's suppose you've decided that 10 pixels is a good size to go back. So you go back 10 pixels, okay, and that gives you this point. Now it's just a matter of finding a line perpendicular to this line at this point, right? Well, that's easy to do. In order to get a perpendicular, you just invert the x's and y's and put a minus sign on one or the other. Okay, it's either going to be this way or that way, depending on which one gets the minus sign. But that doesn't matter. That means I can draw lines perpendicular from this point. So suppose I did that, and draw them in red. I make a unit vector in either direction, and draw, not draw, but in my head I draw this line and this line, right? Let's say 10 pixels. So I take the point I've got and the direction I've got, and let s equal 10 or whatever, the parameter, and that gives me 2 points. And now I've got 3 points, and I make 2 vectors, one connecting these 2 points and another one connecting these 2 points. You wouldn't see the red ones, and actually that would be in the same color as this. So that's a very simple graphical object to build. Then I can just draw vectors and easily explain the things I want to explain. But I wanted to show you some of the nifty little things that I've made. I have broken let's see what happens if I try to, oh yeah, watch this. Oh, it's really slow. I wonder why it's doing it. See how it changes from one to the other. I wonder what it's actually doing. Because I changed the way I calculate some lengths of things, so obviously that messed it up. These were memory leaks, are just the type name. Anyway, I'm going to let this be short, and I'll get back to you when I fix a few more bugs and get this going. See you.